seminar. Ángel will tell us something about debuggers today, so
vale. Bueno, gracias a todos por venir. Esta es la... retomamos de nuevo este año los seminars, que no sé si por si alguno no se acuerda. Básicamente la idea era que íbamos a hacer más o menos con una regularidad mensual. ¿Sí? Okay. Any complaints about having it in English? No? Nobody? Okay. So, well, this is the first seminar for a long time. Basically, the seminars, if someone doesn't remember, the idea is to have short technical talks about something related to computer science, maybe 30 minutes, 40 minutes, it depends, but not much longer. So basically a practical seminar to show some tool that can be useful to researchers here at the Institute, okay? So today what we're going to talk about is the debugger, which is basically a very easy to use tool that lets you find bugs in your program. The picture comes from one of the books that is here in the library. The term debug, apparently the first time it was used with related to finding bugs in software was because there was a real bug, a moth, somewhere in one of the pieces of the computer. So basically that's the picture about. Obviously today we don't deal with real bugs, we just deal with software bugs, okay? So the basic concept for a debugger are quite simple. Basically the only thing it does is it's a program execution platform that allows you to run the program step by step or stop at some point, view the values of variables at certain places, etc. Right? So, for instance, we can have breakpoints, which will be points where we want to stop. We can have conditional breakpoints, so we tell the debugger that we want to stop at this line only if some condition is met. We can do single stepping, so we can go line by line. We can have temporary breakpoints, and we can also inspect at any time the values of program variables. So we can check what is the value at some point. We can modify the value of the variable, so we can check what would happen if this variable is 5 instead of 4, whatever, right? And, well, the other two things, evaluating arbitrary expressions and calling arbitrary routines, we will see that that's quite useful as well. And the last one, moving up and down the call stack, I think it would be understood better with an example. Okay. So basically, well, there are many different interfaces, and they are basically debuggers for any decent programming language. Okay. So the examples I'm going to have here is with Fortran. Basically, it doesn't matter which programming language you use. If it's a decent programming language, there should be a debugger. Okay. Python, Perl, Fortran, C, whatever. And for any debugger, well, there are many different interfaces. So, for instance, I just list here a few. GDB is the GNU debugger. You can run it in text mode, in graphical user interface mode. The DDD is quite popular to run with GDB. You can also have integrated development environments like Eclipse, or IDB is the one I will use, which is the one from Intel Debugger. And you have many more, okay? You can even run, my favorite, you can run Emacs. You can run the debugger inside Emacs. But for today's demo, what we will run is the the graphical interface from the Intel Debugger, which I guess is better for most of you than run it inside Emacs, okay? And the code is a simple Fortran 90 code, but as I said, basically it doesn't matter which programming language you use, there should be a debugger for it, okay? You just have to read the documentation for the programming language, for the compiler that you have, and it should explain how to run it. So the idea basically today is have a demo of things that you can do and to learn about the basic concepts, how you can step through the code and things like this, but not the details of any particular debugger. So basically most of the talk is going to be a demo, okay? Just step into the code, etc. And for that we just have a code that it has some bugs at the beginning, and we will try to find them with the debugger. The code basically is it's a simple code to find anagram words. We have a list of words, And what it has to do is just find word pairs that can be made up of the same letters. For instance, care and race, they have exactly the same letters, so they're anagrams, okay? And this is just some publicity. If you want to have programs like this, we have a forum these days, Algorithm Muffins, here at the CIE. So we have similar programs to this. So if someone is interested in learning about techniques, or algorithm techniques to learn to solve this sort of problems, you can visit that page, okay? Right. So basically, we go straight to the demo. Can you see this from the back, or is it very small? No, right? Okay, I need this just to make the changes to the code and to compile it, but okay. I'm running Windows here, so I ran into the first problem, okay? The debugger just hung. But this shouldn't happen. Okay, this looks better. So the first thing then is, just in case you don't know, just to show how to, well, no, let me first show you the code. This one you can see, right, from the back. Right, so the code is very simple, okay? The only thing it does is, even if you don't understand Fortran, it doesn't matter too much, okay? It's just the concept that will matter. And basically what it does is, at the beginning, we will read a list of words, okay? And we have two arrays. One is words, where we keep the individual words. And then we have lengths, which is another array where we will keep the length of each word. Then basically what we do is get all the combinations of words, starting from the first one to the last. And if they are of the same length, then we are going to call a function that is anagram words, which basically will try to find if these two words share the same letters. And the function, what it does is basically, it has two loops. So in the first one, what we do is take all the letters from the word and just sort them alphabetically. Okay, so if we have cat, we will put A-C-T. Okay? And the second one, basically that's the same for the other word, for the second word. And then at the end, we just compare the two resulting words. So if they are the same, then they are anagram words, and we will print them. Okay, so if they are, this basically what it means is, if they are not anagram words, cycle means just skip the rest of the loop and start all over again. If this is not true, so they are anagram words, we will basically print them. So we can try to see if this is working, which obviously is not going to work, otherwise there would be no much point in having this stuff, right? We wouldn't find any error. So we have the list of the words in one file here, buggy input. Just a list of around 2,000 words, okay? And there are some that are anagrams. But if we run the code, we can compile it with this is again a bit small, right? From the back. How do you make the fonts later in here? Right, so basically I would compile it as usual, I4 minus O, baggy. And if I try to run it, well, it finishes, but it doesn't do anything, okay? So there is some bug. It doesn't find any anagram words, so we have to try and find them. So in order, the first step is to give another option to the compiler. So it will add what is symbolic information, basically information about the names of the variables, the lines in the code, etc. So basically we have to add a -G option. That's more or less the same option for all the compilers I know, okay? Just to add symbolic information, you need that in order to run it in the debugger. It just doesn't do anything except that it will put extra information in the executable file. Without that, if you try to load the executable in the debugger, you won't have any information about the source code or the names of the variables. Basically, it won't work, okay? So once you have that, then what you have to do is start the debugger, which I just did before. And basically, in this case, it's called IDB, and that depends, obviously, okay? And this one is the one. Okay, that's one. And then basically you would load an executable file. This is the file we just created. So we just, in this case, the particular options that don't matter, okay? But the stuff is more or less you can, with any debugger you can do it. For instance, this one, it has a graphical interface, but there are commands to load the file, but we won't go into that sort of detail, okay? So basically we open an executable file, and we can have a working directory, so we will know where to write or read things from. That's the code we just compiled. And then it will load it into memory. You can see here that it was reading the symbols for this file. And we can see the source code. And then what it will do is show me in one window the source code for the file, and then in the other one, this is, well, I have different tabs for different things. Okay, we'll go slowly through some of them. So in order to run the code here, I just have to issue a command. In this case, this button, run or rerun application. I can run it there, and normally well, it says here that the program started, but it doesn't finish. Okay, basically, this is because you see here that it says process is currently running. If you remember the program, what it tries to do is read words from a file, and I'm not redirecting anything. So basically, I did a mistake. I have to stop the program, and then I have an option, rerun with arguments. Okay, so I can. This is just to show that you can put any arguments that you would normally use when you run the application. You can run the arguments as well here inside the debugger. So basically, I just redirect the input, and I put here baggy input. And if I click here aceptar, then it will run the program again with this input. Okay, so it will read everything from there. So it says here started. And in due time, it should say that program exited normally. Okay? So basically, we just run it without stopping at any point or anything like that. Any output that would be created would be shown here in the terminal. Nothing is created because this is the buggy program, right? So what we have to do now is try to find the bug. So we didn't get any anagram words. So what we're going to try to do is, well, first use the options to go step by step through the program. Okay, so basically what we have to do is you see the blue dots here, but that basically means that all of these are executable lines. So we can put a breakpoint in there, in the comments or anything. We cannot stop in there, and neither in the definition of variables. But this one is an executable line. So basically, if we set a breakpoint in there. We can, I don't think you can see it, but there is that changed to red. It says stop. So basically, when the program reaches that line, it will stop, and then we can interact with the debugger to see what's going on. Okay. So now we have to rerun it again. Okay, and as you see, the program says here that it started, but now it has stopped, and it's waiting here for me to do something with it. Okay, so now I have to interact with it. I can do it either through the console. There are some commands like N, for instance, to go to the next line, or normally, in this case, all these buttons are to go through the code in different fashion. So, for instance, this one, it says step program until next source line. So this will go step by step, every line. This one, there is normally an option to go step by step, but if there is a function, a call to a function, you don't want to go inside the function. So you just treat it as one line. Just jump. Do whatever it has to do inside the function, but just don't go inside. If by mistake you go inside a function that you didn't want to, and you want to come out, there is run until caller. So it will do all the code inside the function without stopping, and then it will stop at the point where that function was called. So let's try these commands. Okay, so if I just click next, you see the code is here now. If I click just next, it goes to the next line. And well, this is going to reach around 2,000 words, so we don't want to stay here clicking 2,000 times this command. So we can also have, there is a command to go all the way to a particular line, like a temporary breakpoint. Okay, so in this case, if I continue executing this will be very tedious, obviously, because it has to be 2,000 reads from a file. So I can just say, okay, just go all the way to this line. Now it's here, and at this point, it has done this, the whole loop, so it has read 2,000 words. And now I can go through the code to show the other commands. So I can go a step here to go to the next line, step here, and this is the next one is a function call. Okay, this was the anagram word. So if I click a step again, I go inside the function, and I will do a step by step every single line inside the function. Let's say that that was a mistake. I just wanted to run the function, but without going into the details. So I can click this one, run until caller. So it will go through all the code inside the function, and it will bring me back to the point where it was called. So with this one, it just finished, and it was in this place. Okay. If I continue doing the step program, I go through a few more loops, and now in this case, I can press the other one, which is next line, but treating functions as just one line. Okay, so in this case, if I press this button, which is the command next, it will just step through that, and it won't go inside. Okay, so that's more or less how you would just go line by line doing through the code, right? And at any point, you can have a pick at the variables, at the values. For instance, you can have, there is a command print. So at this point, we are inside this loop. We can have, for instance, print count, and it will tell us that the count variable is still number 1. We can have print I, and that's value 3, etc. Right? There is a more convenient way to see the values of variables, which is the tab locals, which shows all the variables that are in a scope at that moment, and the values. Okay, so we have the variable count, we have the variable I, and the array lengths, the array word, and the array word. So that's quite convenient to see all variables at a glance. Okay, all of them at the same time. Right. So we're going to try and find the error, or the errors. Maybe there are a few more. So at this point, we have only this breakpoint. We can delete it completely, or just disable it. At some point, maybe we don't want to to delete it completely, but we don't want to stop at this point, so we just disable. It's grayed out. And then we're going to put another breakpoint in this line, okay, which is number 45, and it's inside the function anagram. It doesn't. The code wasn't finding any anagram word, so we assume that the problem is something inside the function. Maybe it doesn't do it properly. So we're going to set a breakpoint in there, and then we run it again. Okay, and it's there, right? So all the previous code has been executed, so all the words have been read, and this is the first time that we go inside the function anagram word. This, as I told you, this was meant to, we're only meant to go inside this function if the words had the same length. And then we were going to compare if they were anagrams. So in this function, what we do is, we have two arguments, WA and WB, which is the length of the index of the two words, okay? And then we have two variables here, A and B, which are going to be the actual words for these indexes. So we are at this point here, in this anagram words equal true. We can step these two commands. So at this point, we have the two words that we are going to compare, A and B. So with the local step, or with the print commands, if you want, from the console, it's the same, but it's more convenient here with the local tabs. You can see the values of A and B. The value of A is the word A, and the value of B is the word ability. So obviously this is the first mistake, right? We were supposed to go here only if they had the same length, and they don't have the same length. So at some point, the error doesn't seem to be inside the function, it seems to be in the way we call it. Okay, we are supposed to call it only if they are the same length, and that didn't happen. So then we can go through the code, see where we call it. We were calling it in here, and the first mistake, it's in here. Okay, so at least it quickly shows you that the error is not inside the function, but it's outside in the way we call it, and we didn't have to change any of the source code, which is the best thing. If you're trying to debug and you start putting prints, if the program is long, at the end you end up with loads of prints, with loads of output in the terminal, and it's very messy. Okay, so this is the problem, because basically what we do here is, if the lengths are equal, then we cycle, so we continue, and we should do it the opposite. If the lengths of the two words are not the same, then we cycle, and if they are the same, we go to the next line to check if they are anagrams. Okay. So once we have found that this is an error, we can just go and edit it and correct it. We don't have to leave the debugger. Okay, we don't close the debugger and start again. We just go to the editor and change it in the source code. Not equal. And then we just compile it again. Once you compile it again, you can just load the code again with the same. The same doesn't change at all. And then you see that the code has already changed. And the good thing about this, not leaving the debugger, is that all the breakpoints and everything is still there. So in a debugging session, you will go change the code, load the executable file again, and then everything is still in place. Nothing has changed. Okay. Well, obviously, if you change many parts of the code, then the breakpoints at the end are going to suffer. If you delete the line where the breakpoint was and things like this, and obviously the debugger cannot do miracles. But if it's a small change, the breakpoints and all the rest of the things will be there. Okay. Okay. So now we have corrected that. So we're going to check if the error that was happening before is not happening anymore. So now when we go inside the function anagram word, the words should have the same length. So let's just check if that's the case. Okay, so we just rerun the code, and we have stopped in there. An anagram words equal true. We just step a couple of times to get these variables updated, and we see that A is the word A, and B is the word I. So it seems like it's working okay, right? We can check. This is only one letter word, so we can check again. We don't have to step again line by line. There is always an option which is just continue. So continue all the way until you find another breakpoint or another condition to stop. And the only breakpoint at the moment is this one. So we just click continue, and it will run the program again until it finds the next breakpoint, which is the same one. So we are trying to see the next example, the next time that the function is called. And in this case, we can see that the word was ability and absence, which is also the same length. So it seems to be, at least the function is now okay. So we can disable this breakpoint and let it run to completion. So we just click continue, okay? And on the console, it tells you that the program exited normally. And so now we can see if we actually got any results. The results should be here in the terminal when you call the debugger. Nothing is there, so we have another bug, right? Right. So we know that the function is called with word the same length, but for some reason it seems that it's not finding any anagram words. Okay. So what we can do is enable this breakpoint again and rerun it. Basically, what we would like to do now is to go into this function when we know that the words are real anagram, and to see why it's not finding them. Okay, so if we go through the similar steps that we did before, and we stop in here, now the problem is that we find that when we instantiate A and B, most of the times these are words that are not anagrams. So if we do it like this, we will end up trying to find what's wrong with the code, but with words that they are not anagrams. So we would like to go directly to words that we know for sure that they are anagrams. So how can we do that? So the first, basically two ways, okay? If we continue and start in the function, now we have that WA is the index 2. So we're trying to compare the word with the index 2 to the word with index 6. So basically we can change the indexes, okay? For any of the arguments or any of the variables, we can just change the values. So we're going to, even if we went into the call with arguments 2 and 6, we just change it. And we put 6 and 6, okay? So when we get the word for A and B, it's going to be the same word because they have the same index. So obviously it should be an anagram. So we can see then why it's not behaving properly, okay? So this is an important feature, that you can take any variable and change the value. So you can see what would happen if this value if this variable had this value. So now in this case we can just then instead of stopping, well, we can verify that it's going to be the same word. So after we run these two lines, we see that A is absent and B is absent. So it should return as an anagram, right? Because it's trivial that it would be an anagram. So the first loop was, as I told you, to sort out all the letters in the words in ascending order. So we can just verify that that's working properly. So we can go like before, just say go here. So to the first line outside the loop. So at that point, the first word, which is word A, should be sorted out in ascending order, and it looks like it's working okay, right? Absent, like that. So also all those letters are in ascending order. Now we do the same for the second loop, which is for the word B, and we tell him to go all the way to this line, go here. And then we see that the word B is sorted, but in the wrong way. So obviously, even if they are anagrams, it's not going to find them because they are sorted in a different way. So obviously the problem is in this loop. Okay, this loop is not sorting them properly. So if you just compare both codes for the word A and for the word B, here it's missing. Okay, one variable. Here we're trying. I'm not going to explain how it's done. Okay, but it doesn't matter. I mean, it's trying to do the same thing, and in this second loop, we're going from J from I plus 1 to the length of the word, and in this loop I forgot to put the I, so it's not doing it right. Okay. So we are going to do as before, modified in the source code. So we just add here the I plus 1 and compile it again. Okay. Okay, and then we can reload it, and now you see that it's the way it should be, right? So at least we have found a second bug. This is one way that we can test for a function with any parameters that we want. Okay, instead of waiting for the right parameters to be in place, we can just modify the values of the variables and then make sure that we check the function with whatever values we are interested in. The other way we can do it is to call directly a function. Okay? If our program has functions and subroutines, at any point, even if it's not the way that the program would actually execute, we can at any point call a function and see how it behaves. We may think that the problem is with a particular function, so we just want to run that one with any arguments that we want. So we're going to enable this breakpoint again. It was previously set in there, and we rerun the code. So at this point we have stopped in here. Well, this is the first loop that reads the word, so we have to at least run that piece of code. So we're going to run up to here. So now we are in this line, and what we can do is, remember that we wanted to check if anagram was working okay now. So instead of going into the function and modifying the values for the parameters, we can just make a call to this function. Okay, so we can just type here in the console, we can just call anagram words with two words that we know for sure that they are anagrams. So again, any index will do, 815, 815. And then when we do that, you see, we go immediately inside the function. We are not following the normal path of the code. We're just going directly into this function, and then we could do the same as we did before. Just step through the code and see if it's working okay. Now we can just verify that this change did the right thing. So we skip the loops, and we run all the way up to here, and we can check the values for these variables at this point. And we see that A is inot and B is inot. Okay, so both of them are sorted now properly. So now if we run through this comparison, we're trying to find if A is not equal B, and obviously now they are equal, so we don't run this line, and now the function would return true. Okay, so those are the both ways that you can test a function with the values that you're interested. Right. Only a few more things. There are more advanced things that you can do with the debugger. Okay, you can do conditional breakpoints with actions attached. So on a breakpoint, you can say, okay, when reach this point, instead of just stopping, I can tell the debugger, do whatever I want. I can print stuff, I can load all the programs. Any command that is part of the debugger, you could do at that point. But we're not going to go into so much detail, okay? But maybe the one that could be interesting perhaps is maybe to modify this breakpoint to have a conditional breakpoint. At this point, well, this is another tab to show all the breakpoints, and this one is inside the anagram words function is this one in line 45. So we can modify that one, and we can put a condition, okay? A condition on the variables that are in scope at that moment. So we can say, for instance, the condition is that WA is greater than 100. Okay, so basically we're going to stop in there, but only if the value that we give to the function, the first one, WA, is greater than 100. So for instance, if we save it and we rerun it, okay, we have stopped here. Let me disable this breakpoint, and then we continue. And at this point, we are inside the function, but if we go to the locals, you see that the WA is 101. So we went through the first 100, well, not to the first 100 loops, but every call to this function which value to WA was smaller than 100, we skipped, and we only stopped in this one. Okay, what sort of other things we can do? We can also, what it's called, attach to a running program. There are some points where you have a program and it's not convenient to start it from the beginning in the debugger. Maybe the application is very complex and it has to interact with other programs, whatever. So you want it to start only you want to start the program on its own, and then you want to attach the debugger in the middle of the execution. Okay? So, for instance, we can have that in two ways. The first one, because I'm taking a bit longer than it should, I'm going to skip the first one and go to the second one. Okay? But sometimes I just explain you what we would do. Okay? You could have in a program a code similar to this one, which is an infinite loop. Okay, so we have we set a variable to true, and we say unless it's not true, well, if it's true, exit. Okay, and if it's true, keep inside the loop. So if we uncomment this code and run it, then the program will start and will stay there continuously. So then we can attach to the program. I show you now how we attach to the program. Then we modify the value of cont to be false, and then we continue. And then it will exit the loop and continue in the next line. Okay. Other thing that can be useful is when this is an infinite loop that we do it on purpose, because it's convenient for us to load the program independently from the debugger, and at some point we want to get the debugger attached to this process. Okay. But at some other points, what happens is that the infinite loop is accidental. So you have a code, and suddenly you made a mess of the variables that control a loop, and starts going forever, right? And you also want to touch to that process in the middle of the execution to see which loop is responsible for that infinite stuff. So here, if I change the code again, let me just change it here, and okay, if I leave it like this, you will see now the code. This is going to have an infinite loop. Basically now I commented this line, so now there is a loop without any condition, okay? And I'm not modifying any the count variable is not being modified here, so this is going to go forever. If we just run it now, from the command line, okay, this would never stop. Okay, it just goes into that loop. We don't know what's happening, so what we can do is tell the debugger now to attach to that program that is already running. So there is an option here, attach to process, and we can select here the one we want. Now there are two called, I don't know which one is the right one. Let me, okay, yeah, this one, right? No, this one. Okay, so it's attached now, and it tells you in which line is executing. It's obviously inside that loop. Okay, so now we can just step a few times through the code, and we can see in the locals that the variable count is never changing. Okay. Well, at least it's an indication of where is the loop happening. It's staying in there, so you can look at the code and see what's going on. You can run it, you can let it run many times. For instance, there is also an option in the breakpoint that you say break in this line, but only skip 100 breaks. So just normally a breakpoint will stop every time it reaches that point, but you can say stop only 1 out of 100 times. Okay, so you can let it run for 100 times. Let it run for 1,000 times, and you will see that count is always 1. So obviously something is going wrong. It's never updated, so we have to change that line. And okay, and the last thing I want to show is also what is quite common. I'm sure that you all had at some point a segmentation fault. Horrible. You have no idea what happened, right? Segmentation fault, and how do you deal with that? Okay, so you can also, once you have attached, you can, previous example, you attach to a program, and at some point you find what's the problem, and you can detach from process. Okay, so it's just the debugger is not taking control of that anymore, and now you can, it's running as a normal program. You can stop it as you would with any other program. Now, the last thing that I want to show you is what to do with those segmentation faults, which is, the debugger is quite useful for them as well. If we uncomment these two lines, I show you now with bigger font. Well, first, to verify that it gives a segmentation fault, I run it there, and it crashes. Okay, segmentation fault. No idea what happened. So we can just load this in the debugger as well, and what we did basically was comment this line. It was going through a loop from variable I from one value to the number of words that we have, okay, and just change it to the upper limit is n words plus times 20. So when we are trying to access the length, for instance, or the actual word with this index, obviously that's not going to be there. It's 20 times bigger than it should, right? So it gave you a segmentation fault. We can just load it and run it. Okay. And if we see the console, it tells you here, well, the program started at some point, a starting program, and we got a segmentation fault. Right? So now, what do you do with this? There is another option to see what is called the call stack. Every time you call a function, there is a lot of information kept about the variables and the status of pointers, etc. That is kept. And every time you make a new function call, a new level is added to that call stack. Okay, so you can see the call stack here, and it will tell you the first one is really the last one that was called. Okay, so it goes the other way around. So you see that the program started here. This is the function main. This is at some point we were here in this line 32. Then this one called this function anagram words, and this function anagram words called this mem copy, that is an internal fault. Okay, so we know that this is the last cause of final cause of the segmentation fault. But if we want to see which line in our code made this error, we can go to the previous level at the stack. Okay, so we can see. You see, there is an option here, always set scope. So, well, only by looking at the line, we have an indication of what went wrong. Okay, something in this program, line 48. When we're trying to do this instruction called an internal routine memory copy, and this one crashed. Okay, so well, actually, just by looking at this call, you already could see what's the problem. But also, we can do set scope, and this will set the values of the variables that were at this point before the mem copy was called. So you can inspect the values at this point. So we can see the local in the local tabs. We can see the values that were right before the program crashed. So we can see that A was the letter A, B was the letter I, and well, this is not really relevant because probably wasn't. I mean, this instruction didn't finish. But what is relevant is that you can see the values for the argument here, WA and WB. These are the indexes of the words. This WA is 1, WB is 10,000. Okay, the maximum words is 1,700, something like that. So you can see that that's a problem. Okay, actually from here you could already see the values of the arguments. But if the problem is not in the argument, you can just change to that moment in time when that function was called, and you can inspect the values. So now segmentation fault don't seem so scary, right? And well, there are also other things that you can do. Also, when there is a segmentation fault, normally it says a core file is created. So that's just a file that keeps like the state in memory of everything that was happening at that time in the program. So you can load that file as well. There is an option here to open a core dump. So you would tell the debugger which one is the executable file and which one is the core file. So once you load both things, it's similar to what we did, but you don't have to run the code inside the debugger. I mean, you run the code outside, and you just load the core file, and it will tell you the same thing that we had in here. So you could see the values of each variable before any function was called. You can also do things like what is called a watch point. So you can take a variable and say, you can say, don't stop at a particular line in the code. Just stop whenever the variable x is written or is read or things like this. And it doesn't matter how many places it's in the program. Anytime that is modified, it will stop. And as I said before, you can also set, for instance, actions together with a breakpoint. So you say, at this time, in this line, instead of stopping, just, for instance, print a value of another variable or things like this. Okay, you can make different actions, but we don't have time for all that. With a good debugger, you can also check low-level things, like you can check the values that the internal registers of the CPU have, a dump of all the contents in memory, and etc. But I guess most of you probably don't program that low level, so probably not much of interest. Right, so that's the demo. I hope I forgot to say at the beginning that if you wanted to stop me when I was talking, you should. Now it's a bit too late, but I hope more or less it was clear. There is I just put here some references if someone wants to know a bit more. I didn't put any extensive list or anything because the documentation depends on the programming language and on the individual debuggers, so you have to read that information. But I just put the reference for what I use, okay, in the talk. So this book is in the library, which is basically, that's where the image came from, The Art of Debugging. So it gives you not only tips about, I mean, not only shows you how to use a particular debugger, but it gives you tips about how to go about debugging, okay? So it's common techniques or what to do to find different types of problems, so it's quite nice. and then just the reference for the Intel Debugger, which is available to all of you here in the Institute. And, well, I didn't show it, but also, well, this debugger is not really the default at the moment, but I think we will install it probably, this version of Intel and the Intel Debugger. And this one has an online, quite nice online help, okay? So to find the syntax of a particular command or whatever, you can find it there. Right, so that's all I had to say. I went above the limits that I was supposing. And, well, I think you all know me, but in any case, the contact info, if you have any doubts or you want to start using the debugger, whatever, you can check it there. Any questions? Was it too much? Or?
We need to use the debugger specific to that compiler. I mean, can you tell the debugger to debug a normal
You can, but it's not very nice. I mean, sometimes it doesn't work very well because the debugger, each compiler puts some particular information, and then when you try to debug with another one, some options don't work. Actually, it also depends on the programming language. For instance, with Fortran, some things here don't work properly with this debugger. So, for instance, if you have strings, you cannot change the value of the strings. It tells you that it's not supported, things like this. So, it's always recommended if you're going to debug with Intel Debugger, compile it with Intel Debugger. And if you're going to debug it with GDB, compile it with Fortran, because otherwise things cannot be as expected.
More questions? Clarifications? Everything's clear? Okay, then thanks, the speaker.
So now we start using it. Right. So it was